Hi, this is Jayanpati. I'm here to give the presentation of my final report in research methods 955. So here is my topic name, the mechanical properties of high strength concrete. Um, Here's a table of content. So here is the abstract. The abstract mainly explained about the substitutes and the technology which improve the characteristic properties of component strength like the tensile flexure and split tensile test. So the abstracts also tells about the um, supplementary cementitious materials which eventually improve the compressive strength of concrete by adding the to 70 megapascals like to 80 megapascals. So also, there are AI driven technologies which which is conducted by the researchers to know the comparison parameter. So when they are doing that, the test results, the lab test results, and the AI driven results, they are matching each other, and so this implies that um, the artificial intelligence and machine learning tools which eventually give the same results as of the lab study so that the time will be saved. So coming to the introduction, concrete is important material used in the construction site across the nations due to its workability, durability, and high load bearing capacity. So the replacements like bagasse, GEBs, and brass furnace will eventually improve the compression and tensile properties of the concrete. And the mixed design ratio and workability are among the better outcome. So in today's stance, the machine learning algorithm has become to detect the sim results rather than lab study data in the to extent. So the same results have been approached. So the substitute metals in cement like fly ash, um, a byproduct a combination combustion will improve the workability and durability of the structures. And researchers also explained four case studies resulted that 40% of activated fly ash and 1.7 coconut fiber will improve the performance of RAC and tensile strength to 30 degrees, which is like a great thing. So here is a literature review which explains the artificial intelligence and machine learning, which is like the best accurate thing to get the results to the response surface methodology, which predict the strength properties like compression and curing. And then here comes the figure which represents the temperature versus mass loss at 800 degrees Celsius. And here are the figure which represents the compression in megapascal at 1728 units of strength. Um, so here is a table which represents the characteristic properties of OPC and fly ash even. So these are some properties like specific gravity, fineness, consistency, and setting times. So so here is the research design question. So what is the mixed design ratio of substitute or additive which are added in the cement to get the best performance of high strength concrete? So here is a methodology. Um, Here is like test analysis. There are like four tests: split tangent test, flexure test, durability test, and compression. So These tests are conducted like within 1728 days of curing time to examine the strength the properties of concrete um when the specimens are put into 7 and 28 days of curing time period. So, so here is a type of concrete, the compressive strength and time period. So here is a different types of concrete. The red mud concrete, the compressive strength is like 8 to 11 megapascal over 1 to 7 days curing period. So these are some of the other concrete structures and the compositions. So and figure which represents the water to ultra fine performance concrete. So so here are some of the references, and here is the literature planet. So the final conclusion is that the substitutes like GGBS, bash, furnace slag, and silica fumes, and the substrate. So which eventually improves the strength parameters of concrete by adding it, so that the structures will attain the high loading bearing capacity uh, in radiation fields like hospitals areas. So it can withstand much loading bearing capacity, and the lifespan of the structures will also increases eventually. So here is my part of presentation, and thank you.